All right, so hello class. What we're going to do today is we're going to learn how to solve systems by using a method called substitution. So in the last lesson, we learned how to solve systems by graphing, but sometimes when you try to graph the system, you might end up with a situation like this, where when you look at the solution here, it's somewhere in between. It's not directly on a grid mark, and so you'd have to estimate that solution. So sometimes it's very difficult to solve for the exact solution by graphing. And in that case, what we can do is we can solve systems algebraically. So there's a couple different methods that you're going to be learning to do this, and the first method, which we're going to go over today in this video, is solving by substitution. So we're going to go through a few examples, and then you can give it a try. Okay, so this first system, solve by substitution. Pause the video, write down the system, and then come back and it'll walk you through it. Okay, so we're going to solve this system by substitution. And so what we're going to look at is you have 2x plus y equals 5 in the first equation, and y in the second equation is equal to x minus 4. You can't solve either one of these equations for x or y with one equation because we have two unknowns and only one equation. But when there's a system, there's a relationship here that we can find, and we can solve for x and y. The one xy ordered pair that would where the two lines would intersect. So here's what we're going to do. In the second equation, we have this fact that y is equal to x minus 4. So what I'm going to do is I'm going to take that x minus 4 and I'm going to substitute it in for y in the first equation. So this is why it's called the substitution method. We're going to substitute in this expression right here for that y in equation 1. So we have the 2x plus, and instead of y, I'm going to write x minus 4. So I just substituted that in place of the y, since y is equal to that, and then that's equal to 5. Now we have one equation, we have one variable, and we can solve this equation for x. So simplifying this, I don't need those parentheses. I put them there just for you to see that I'm putting that whole expression in for y. Combine your like terms. What is 2x plus x? It's 3x. And then I have minus 4 equals 5. And you keep going here. It's the opposite. You're going to get the 3x by itself, so we've got to get rid of minus 4. So the opposite of subtraction is addition. So we're going to add 4 to both sides, and we end up with 3x on the left. And on the right side, we have 9. And keep going. We're going to divide by 3. Divide by 3, and we get x is equal to 3. But now remember, we're solving for an ordered pair, and all we have right now is the x coordinate. Put that in a box so you don't lose track of it. Now we need to solve for y. So we're going to take this, and now we're going to substitute that value of x that we just found into either one of the equations, but the second one is going to be a little bit easier. So I'm going to find y by putting 3 in for x, putting it in right here, taking this equation, and I'm substituting the value of x that we just found, and now I'm going to solve for y, so get y equals 3 minus 4, which is negative 1. So the point where these two graphs would intersect would be the ordered pair 3, comma, negative 1, and this would be our solution to the system, as long as I didn't make any mistakes. So, how do you figure out if it is indeed the correct solution? We're going to check it. So once you stop the video, plug in 3 for x, plug in negative 1 for y into both equations to determine if it really truly is indeed a solution to the system. Okay, so we're going to take 2 times 3 plus negative 1. Does that equal 5? This would be 6 plus negative 1, or 6 minus 1. That's equal to 5. But remember, I got to check it in the second one as well. So plugging in, I'm going to this one. Negative 1 for y. Does that equal 3 minus 4. 3 minus 4 is negative 1. So yes, indeed, it checks out. This is our solution right here. Okay, next example. Again, pause the video and and write down the example. Okay, for this guy, we have the first equation is solved for x. X is equal to 2y minus 4. So what I'm going to do with that is I'm going to substitute that in to the second equation. I'm going to put that in place of x. Since x is equal to 2y minus 4, I can just substitute that in. This is going to go right in here. So I end up with, instead of writing x, I'm going to write 2y minus 4. And then I continue on. I've got the plus 8y equals 16. Now this time I have a single equation with a single variable involved, which is y this time. And it just depends on which equation is solved for which variable. We started with one of the equations was solved for x, so we substituted that in, and now everything's in terms of y. So we're going to, again, combine our like terms. We've got 2y plus 8y, that's 10y, minus 4 equals 16. And then continue on and solve for y. Why don't you pause the video, solve for y, and then plug that value of y back into one of the equations. Equation 1 will be easier, and figure out what x is. Okay, welcome back. We got 10y is equal to 20. Divide both sides by 10. And you should have gotten y is equal to 2. And there's the bell. But that doesn't mean you can leave class. You gotta keep watching the video. Okay, so y is 2. I'm going to plug it back in here. Oh, let me pause this. Okay, interrupted by the bell, but your class is not out. Not yet. Okay, you guys, we're going to, where were we? So we just figured out that y was equal to 2. We're going to substitute that back into either equation here, 1 or 2. 1 is already solved for x. I think that's going to be easier for us to figure out what x is equal to. So I'm going to plug in this 2 in place of the y. So 2 times 2 minus 4. And we get x is equal to 4 minus 4, which is 0. So x is 0 and y is 2. My solution is that ordered pair 0, 2. Which means if you were to graph both of these equations, they would intersect at the point 0, 2. And that's the one point that they would have in common. I want you guys to stop, check the solution, plug in 0 for x, plug in 2 for y, and you should see that both that the solution will work for both of the equations. Okay. Next example. Pause the video, write it down, and I would like you to try to do it by yourself, and then come back, and I will I'll go through the steps with you. Okay, so we have for this one's a little bit different because here both equations are solved for the variable y, but it's the same concept. What we can do, you can pick either one of these equations actually, and y is equal to x plus 3 in the first equation, so I can substitute that in for y in the second equation. So what we are going to be looking at is, in place of the y, I'm going to put in x plus 3. And then on the other side, I have 2x plus 5. I've got one equation, x's, that involves just x. And there's x's on both sides, so what I need to do is I need to get the x on the same side. To do that, we're going to subtract x. On the left side, I have 3. On the right side, I have x plus 5. Keep going, subtract 5, and I get x, over here, x equals 3 minus 5, which is negative 2. Don't forget the little negative sign. Now I have, I know that x is negative 2, I have to figure out what y is, and you can use either one of the equations. To me, number 1 looks a little bit easier, so I'm going to plug in negative 2 in place of this x right here, plus 3 to find y. Negative 2 plus 3 is 1. So my y coordinate is 1. So solution to this problem is -2, 1. Check it. Hopefully you've already checked it. You did it by yourself and checked it and it worked. If not, do it with me right now. So in place of for the top equation, I'm going to replace y with 1, and I'm going to replace x with -2. Does 1, I'm checking, so I'm going to put a question mark, does 1 equal -2 plus 3? Yes. And then checking the second equation, I'm going to put 1 in for y, and I have 2 times, put -2 in for this x, plus 5. 1, is that equal to -4 plus 5? Yes. That's 1, and this side is 1. It checks. Okay. One more example here. This one, neither of the equations is solved for either variable, but if you look, we could either solve equation 1 for y, or we could solve equation 2, the bottom equation, for either x or y. Why don't you write down this system and try to do this one on your own, and then come back and work through it with me if you get stuck. Okay, so I'm going to solve equation 2 for y. I'm going to solve this for y. So if I do that, I have x plus y equals -7. Solving that for y, I'm just going to subtract x from both sides. On the left side, I have y, and on the right side, I end up with -7 minus x. They are not like terms, so I can't simplify that any further. That's it. So now I have y equals -7 minus x. So I'm going to take and replace this y right here in the top equation with what it's equal to, -7 minus x. We just determine that. So I'm plugging that in. I'm going to use substitution. I'm going to substitute in place of this y what it's equal to in terms of x. So I have this 2x plus, instead of y, I'm going to write -7 minus x. I don't need those parentheses. Let me get rid of that. And then that's equal to -4. And take away those parentheses. 2x minus 7 minus x equals -4. Combine your like terms. You got 2x minus 1x. 2x minus x is 1x. You just leave it as an x. Minus 7 equals -4. Continuing to solve. We're going to add 7, and we end up with x equals 3. So we know our x value, now we need to solve for y. And to me, this equation looks easier to use, so I'm going to put in 3 for the x. So now we're solving for y. Plus y equals -7. Subtract 3, and I end up with y equals -10. So my solution to the system is 3, -10. You can check that, pause the video and check it, make sure that it works. And then what I want you to do is on the next slide, I'm going to write down the steps for solving by substitution. Again, you're going to pause the video, write down those steps, and put those in your notes, okay? Okay, our steps to solve by substitution. Step 1, solve in one of the equations for one of the variables. This step might not be necessary. I think 3 of our examples you didn't need to do that, but in the 4th one you did. Step 2, substitute the resulting expression into the other equation. Step 3, solve that equation to get the value of the first variable. Step 4, substitute that value back into either one of the original equations and solve for the other variable. And then you're going to write the solution as an ordered pair. Make sure you do that. And then always, always, always check your solution. Okay, that's it.